one last video for 1.3.3. So I wanted to make sure I did one application problem in here of multiplying radicals. So this question, I really like. It ties together quite a few of the things that we've had to do so far. We're looking at two 32-inch TVs. Maybe kind of an old problem. 32 inches getting to be sort of a small one. I don't know, maybe I'm spoiled. But a 32-inch TV has a 32-inch diagonal, so it can have different dimensions. And what we're looking at here is one that's a little less of a widescreen, 25 inches, and one that's a little more of a widescreen, 28 inches. And we want to figure out which one is actually giving us more screen area. Okay, so starting places. Word problems, it can be really hard to start for people. And this one does have several pieces. So starting with the question can sometimes be helpful. We're asked for area. So if we're looking at these TVs, I'm going to call this one TV1 and this one TV2. Both of them are rectangles. So we're going to be using area equals length times width. When I have a lot of information floating around, diagonal, length, width, area, sometimes I actually prefer to just write it out in words, because otherwise you get A's and L's and C's and A's and B's, which we probably will get anyways, because I don't know if I want to write those out in words, but up to you, not a mandatory thing. I like to sometimes just write out in words instead of having more letters on their own. So we really want to know what area 1 and what area 2 are going to be. And both of them were given one dimension, so let's call that the length. So area 1 has a length of 25, area 2 has a length of 28. But we're not given the width, so let's call this the width for both of them. Should be a little bit different, but it's that vertical distance on the TV screen. So we're going to have to go do some side work to get the width. So now, looking back at the problem, I've used the 25 inches, I've used the 28 inches. I need to find another dimension. I don't just have free choice to choose any old, okay, if the bottom is 28, maybe I want the top to be 15. The thing that's restricting my choice is the fact that the diagonal has to be 32. So if you can look at a problem and ask yourself, do I have free choice or is something restricting it? Often you can point yourself in the direction of the piece of information you need. So I need to use the information that the hypotenuse of that triangle I just drew has to be 32 and the base has to be 28. So we're going to jump a little ways back now. We reviewed a little bit of the Pythagorean theorem early on. I think it might have even been in chapter 1. If you're comfortable with the manipulation, you can just start with a squared plus b squared equals c squared and rearrange, plug in numbers and rearrange. But just temporarily, I did give you a version that was solved for finding either leg. So it would be that a is equal to the square root of c squared minus b squared. So we will absolutely be able to do that kind of manipulating on our own soon. For now, if you're not feeling comfortable, I did give you those two rearrangements that you can use. Okay, so let's call this A1 and this one A2. So A1, I'm probably not giving myself enough room here. Do it down here. Okay, so little a1, which is the what we're calling the width, is the square root of, remember c is always the hypotenuse, so 32 squared minus b, which is the other leg, 28 squared. Okay, so let's see, I'm going to calculator that. I don't really want to figure out 32 squared in my head. So 32 squared is 1,024 minus 28 squared. I don't know what 28 squared is because I didn't ask it that, but I'm getting the square root of 240. And let's think about, why won't that make a line? There's like a dead spot. Hold on. 240. That looks a little better. Okay, we can simplify that a little bit. Let's see, definitely 4 is a factor. 6 times 4, 60. 4 times 60. So I'm thinking we could even get another 4, right? 30. Yep, so 4 times 4 times 15. So it's like a 16 times 15 that I'm looking at. Okay, so I'm going to say that's the square root of 16 times 15, which is 4 root 15. For the second TV, oh, I think I'm switching names. Nope, I'm not. A2. Well, kind of. I was sort of confusing. TV1, I called it A2, and TV2, I called it A1, and I'm sorry, because I think that was not my very best choice. I would just say that you get to choose for you and maybe make better decisions than me. Okay, so the other TV, it's a very similar process, but the known leg is 25 inches instead of 24 inches. So we're going to run through the same process. 32 squared minus 25 squared is 399. 399 at least looks like it's divisible by 9. Oh, no. How is that possible? What am I misthinking here? 300. Oh, I'm sorry. It looks like it's divisible by 3 is what my brain was trying to say to me. So 399, if we divide it by 3, we're going to get 133 times 3. And then 133, that's not looking particularly nice. It's not divisible by 9. It's not divisible by 16. It's not divisible, what's next? 16, 25, no way. Divisible by 36? I don't think so. I think we're pretty stuck on that one, unless I'm not spotting something. Oh yeah, it's definitely, I don't know. I think we're good. I'm going to leave it. If I'm wrong, I'm wrong. It's okay. We're going to convert to a decimal. So back up at the top, for the 25-inch TV, we have a root 399. For the 28-inch TV, we have 4 root 15. 28 times 4, 80. And 32, 112. Root 15. Okay, so we get these two answers, and I didn't follow my units, but they should be square inches. Please do practice. It's a good skill. I have not a great idea of which one of those is bigger. So this is a good example of where I absolutely think it's a good idea. You can write down the exact answer. Be sure that I can see everything I want to see. But checking out with a calculator a decimal approximation of that, I think is going to be a lot more helpful. Let's see if I can clear out. Okay, so I want to know what 25 root 399 is. 25 root 399, and it's about 499.37. Careful use of that approximately equal to is another thing to try and be thoughtful about. I know sometimes I forget to do that, but most of the time I think I'm pretty good, and I would encourage you to try as well. I have no intention of picking on you and hurting your grade over every little detail, but I'm going to keep bringing them up and bugging you about them so you can try to get better at these things. Okay, and then the other one, I think my pen's getting tired, was 433.77. So actually we get more viewing area from the 25-inch wide TV than the 28-inch wide. Different shaped viewing area, but more area. So lots of messy number work in there. And again, soon it will be messy variable work. Thanks for watching.